For the Kinetics Lab, the first thing we need to do is calculate the rate of the reaction. And we're going to talk about the rate in terms of the change in concentration of the bromate ion over time. First thing we need to do is figure out the number of moles of sodium thiosulfate that we have, because sodium thiosulfate is what eventually causes and determines the number of moles of bromate ions that I have. So in each reaction, we've got half a milliliter, 0.001 molar sodium thiosulfate, and I'm going to find out how many moles of sodium thiosulfate that is. And so I will simply take volume times molarity of the sodium thiosulfate. So I have 0.00050 liters times 0.001 molar, and I get 5.0 times 10 to the negative 7 moles. And this is thiosulfate ion. Now I'm going to set up a mole ratio between the sodium thiosulfate, the iodine, and the bromate to see how many moles of bromate ion I get. So here are my two reactions from the front page. The thiosulfate ion's in the second reaction, and I have a 2-to-1 mole ratio between it and iodine. Iodine is also in the first reaction. That's what reacts with the bromate in the first place. And so there is my mole ratio between iodine and bromate. So I'm going to take the moles of thiosulfate that I found previously. So I have 5.0 times 10 to the negative 7 moles. And I want to get to iodine, and then from iodine to bromate. So my mole ratio, what I want on top, 1 mole of iodine, 2 moles of thiosulfate. My mole ratio in the first reaction between iodine and bromate is 3-to-1. I want bromate, so I have 1 mole of bromate ion over 3 moles of iodine, and that will give me the number of moles of bromate ion that I have present in my solution, or that actually get reacted in my solution. And I end up with 8.33 repeating times 10 to the negative 8th. Okay, it turns out for our reaction that the blue color will begin to appear when all the thiosulfate's used up. And so the change in the bromate ion concentration can be calculated. If I know the number of moles of bromate that got reacted, that's what I just figured out there. And the fact that all the reaction volumes are 6 milliliters. So if I take the change in concentration, in this case 8.33 repeating times 10 to the negative 8 moles of bromate ion, divide by the volume, I'll get the concentration change of the bromate ion. So 1.39 times 10 to the negative 5 molar is the change in concentration of the bromate ion for this reaction. So the change in concentration divided by the time is going to give me the rate. So I'm going to use this value and divide it by each of my reaction times, and that will give me the rate for each reaction. I need to find the order for each reactant, and so I'm going to start out with a rate law. I'm going to include hydrogen ions, bromate ions, iodide ions. Those are the 3 that are in my concentrations. First, I'm going to find the initial concentration. Well, I have the initial concentration of each of those. That was on the bottle of the solutions that I used. So for iodide ion, I used 0.01 molar. And I used, depending on the reaction, either 1, 2, or 3 milliliters. So I'm going to take the molarity times the volume, and that gives me the number of moles of iodine in that particular reactant. And then I'm going to take that number of moles, and I'm going to divide by 6 milliliters, and that gives me the initial concentration of the iodide ion. So I have to do that for each of my 8 reactions, for each of my 3 reactants. Relatively straightforward in terms of finding initial concentrations. So you'll need to do that. We'll check to make sure you've got the correct initial concentrations on Monday. Rate law. Well, what would it be? Start with K. Concentration of iodide ions first in your table, so we'll put it first here. Put it to the N order. Second on your table is bromate, so put it to the M order. Third on your table, hydrogen ion. We'll put it to the P order. Well, as we've looked at before, you're going to do one reactant at a time. So you need to look at the reactions where the concentration of iodide changes, but bromate and hydrogen stay constant. You did 8 reactions. It turns out you're going to be able to do 3 trials for finding the order for N and for M and for P. So let's look at finding N. If we look at our reaction charts and I look at our 8 experiments, the first 3 experiments, bromate ion concentration is constant. Hydrogen ion concentration is constant. So those would be the 3 that I would use to find the order for N. So I'd compare 1 to 2, 1 to 3, 2 to 3. If I want to look and find the order for bromate ion, so find M, I need to find reactions where bromate changes, but iodide and hydrogen ions stay constant. So look through your chart. Turns out we're going to keep coming back to reaction number 1. What are the other 2 experiments that we need to check when we're looking for order for bromate? Hopefully you figured out you're going to use experiments 4 and 5 in addition to number 1. For P, we're looking for the order for hydrogen ion. Again, we're going to use number 1. It comes back to number 1 for each one. The other 2 that we're going to use. Sort of process of elimination. What's left? Hopefully you figured out you're going to use number 6 and 7. So you're going to do 3 trials to find N, 3 trials to find M, and 3 trials to find P. If you would please have those figured out, have all your initial concentrations determined, and have your rate for the 8 reactions calculated for Monday. We'll double check them and then we'll talk about how to find K, make sure everybody has the correct orders once we figure out what they are. So those are the calculations that you need to do over the weekend. Watching the next vodcast would probably be a good idea as well.